that's where you set up your table, and I don't think I'll take the time to write all that. Let's just get results. Liz, do you have this to the nearest tenth?
The total?
Yeah,
You wanna do
grand
it?
total. I don't want to do a
Total?
table, we're just going to jump right in.
I got 122.6.
And what would be the units on that?
For AMU?
I could say AMU, yeah, that's fine, but to be practical trend, we'd say grams per mole. Now, everybody get that okay and know how you get that? All right. Then, I want to know the percent oxygen in here. So, this is one of our many percentage problems. Okay. What's the problem?
Oh, I was just asking because I was
Oh.
confused about why, like, but I was trying to use the equation at the top of 2 KCl over 3.
Oh, no.
That's what you said.
That is a way to do it, but that's coming in chapter 3. And your book introduces something new before they really talk about it. So I'm taking you through something, a way to do it with info you have already. And I assume not everybody has a wonderful background in chemistry from high school, or if they do, they've forgotten most of it. So let's just go after percent oxygen in this compound. Okay, so let's get that set up. All right, and Bruce, what are you getting?
I'm still confused as to why there's a 2 in front of their top and...
That's a chapter 3 stuff that,
Okay, I know you just explained it, but I still...
okay, wait.
When I started working it...
Okay, first of all, I got the wrong number here. That's a problem. Let me get rid of that. Okay, when you balance an equation, and this is a preview of what's coming in chapter 3, that if I have a potassium here, I got to have the very same number over here. And so, conservation of matter. So I've got 2 potassiums here, I got to have 2 potassiums there. If I have 2 chlorines there, I got to have 2 chlorines there. Here's the problem. I got, in the formula, there are 3 oxygens. Because in a formula for some compound, it could be a 1, a 2, a 3, a 4, anything. But when it's hanging out just by itself, it is diatomic. When that oxygen comes off, it's going to bond to itself. So that's just a business about we're balancing the equation. And because this is a 3 and this is a 2, to get the same number, I'm thinking, what's the smallest number I can divide both 3 and 2 into? Well, it's 6. So if I put a 2 here, that gives me 6 oxygens, but if I put a 3 here, it gives me 6. But again, that's coming in chapter 3. Don't lose any sleep over it.
Well, when I
Yeah.
did the formula, I did 2 potassium.
Oh, no.
That's why.
It's just, okay. Normally, this would not even be showing. I just wanted you to see how this would work. Forget the 2. I
Okay.
want. And that's a good point. The formula weight. And notice how Liz or whoever answered this, grams per 1 mole, where that implies 2. But again, coming in chapter 3. But
Okay.
good point. Okay, now let's move on. I want percent oxygen in this compound, and it's always a percent by mass. It's never the number of atoms here. Nikki, in the back, what'd you get?
39.3%.
39.3%. Okay, now, last time we worked one percentage problem from this next to last section. And let me just refresh your memory a little bit. I know it's been a whole week. This is where I said if you were a geologist and you got this big hunk of stuff and you're interested in that particular one, you wanted to know how much chromium you could get out of there if you were trying to mine for chromium. So we had like 200 grams or whatever it was of this chunk of a pure compound. If we totally ripped it apart, how much chromium could we get? Now that was one kind of percentage problem. This is coming at it from another angle, a harder angle. Nina, did you have a question? Or you got an answer?
No, I got the answer.
Okay, hang on for just a moment. What we're saying is, I need 40 grams of oxygen. Do not worry about the 3, do not worry about the 2. I just want 40 grams of oxygen. End of story. How much of this would I have to take? Okay, now, let's look at an answer that some of you have gotten, and then let me tell you if this is a problem, a way to think about this. Nina, what did you get a final answer?
102.
102 grams of KCl O3. So you would have to weigh out, according to her number, and let's assume it's right for the time being, and it may be, we've got to weigh out 102 grams, we've got to totally decompose it, and we've got to collect the oxygen, and if I do that, we're going to get 40 grams of oxygen. Okay? Now, I'm not sure what Nina's reasoning was, but this is what I would do. I would say, I would change my percentage into a decimal form, so 0.393 of what big number is equal to 40 grams. I would have to take 39.3% of something, and this is what we're solving for, this something, to get 40 grams of oxygen. Is that close to your reasoning through that, Nina?
Yes.
Okay, now, when I was back, I can't remember when they started teaching all these percentages and stuff. If I wanted to, I would just take the number and divide, that 0.39, whatever. If I want 40 grams, and I know that's 39%, I didn't understand why I was doing it. I just knew very mechanically, take that number, divide it by 0.393. But what I just said is the reasoning behind that. Our teachers were not big on teaching us or thinking about why. It was just, go do it. And we obeyed back then. But you're really saying, you want to take 39.3% of some big number that will give you 40. And so when you solve, and of course percent has no units, see, I've divided both sides through by 0.393 so that the x, the unknown, stands alone. And I do that. And that 102 sounds a reasonable answer. Is that what other folks got?
Yeah.
Okay. Okay, this is a very practical problem in the laboratory. You need so much of this. How much of this starting material do you have to take to get there? Marco?
X will be like the potassium
Chloride.
Oh,
Yeah.
cool.
How much of the big stuff we need to take? Yeah, Andrew?
So, we need 40 grams, so we're trying to figure out how many grams of
Starting
KCl
material.
do we need to
Mhm.
take in order to get that.
Yep.
So we found the percent of it, so over here, the old, so that was the percent of the
Some big number,
of KCl
yeah.
O3, and we need to divide it by the 40 grams to find that. So,
Yeah. Divide the 40 by the...
yeah.
Yeah. Okay. All right, let's move into chapter 3. So that put chapter 2 to bed. Remember, your test is over chapters 1, 2, and 3. Okay, but the good news is not all of 3. It's going to be like the first 5 sections of 3. All right, let us get started. There's 2 major things in chapter 3 for us, for the test. Okay, chapter 3. First biggie is balancing equations. Now, I know some of you have done this before, and it's no big deal. Great, I'm happy for you. Some people never quite get the hang of it when it's first introduced, and it just takes some practice, but we can all get to the same point at the end. So, let me take one, and this stuff is trial and error. So, section 1 is a thing all by itself, learning how to balance equations. Then, as we get through these next sections, they are all intimately connected with each other. And the basic idea there is how to work what I call weight problems. Now, the fancy term for a weight problem is stoichiometric problems. And don't worry about that word right now. It just means numbers are going to be there. Okay? So, let's first work on balancing.